Good evening, and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I want us to explain example 12 of graphs 8, still looking at transformation and in particular stretch. And I just want to explain these graphs the way they are transformed. And as you can see, the two graphs below show y is equals to fx and y is equals to f2x. And I want to highlight 2x there, plotted on the same axis. In each case, the transformation from y is equals to fx to y is equals to 2x is a stretch scale factor half parallel to the x-axis. And I want just to employ Mayo and use Mayo to explain the two graphs. Let's have Mayo here, the magic table, my magic table. This is minus a 1 over a and a, and Timothy should verify himself. And as you can see, M means multiplication, A means addition, I means inside, and O means outside. S means, or rather T means translation, S means stretch, V means vertical, H means horizontal. Minus A, 1 over A, and A, all those are parameters of transformation. I will explain them in this question as well. We are told that the two graphs show the graph of y is equals to fx. The red one, as you can see, is the graph of y is equals to fx. The black one is the graph of y is equals to, the black one is the y is equals to f2x in both cases. And I want us to analyze this transformation. As you can see, the function, yes, is multiplied from inside by 2. So it is a multiplication inside, as you can see. According to this table, we have a multiplication, and what is multiplying is not multiplying the whole function. We are multiplying the x, what is inside the bracket. So this, by all means, is multiplication inside. Multiplication inside. And according to Mayo, multiplication inside, as you can see, if we can highlight the multiplication, you can see multiplication inside. It gives us a horizontal stretch. Multiplication inside is a horizontal stretch of scale factor 1 over a. This one is giving us a multiplication inside is a horizontal. Let's say it is, as we have seen, horizontal stretch of scale factor 1 over 2. 1 over 2 simply because, as you can see here, our A is 2. So 2 is actually the parameter of transformation here. And it means that horizontal means all x values are affected. And because it is multiplication and therefore a stretch, it means that all x values are going to be multiplied by 1 over a. Multiplication inside a horizontal stretch of scale factor 1 over a. We are here, 1 over a, that one. So, and because our a is 2, because our a, as you can see, is 2, it means we need to multiply all x coordinates by a half. All x coordinate ought to be multiplied by a half. And if I may want to explain now this graph, starting with this one, you can see x at this particular conspicuous point, x is 90. 90 times half is actually 45. And that is why this point has shifted to this point. Remember why values are not changing. Remember why values are not changing. So it means that this point has shifted here. You can see that shift. You can already see that shift. This point is at 180 degrees. 180 degrees times a half becomes 90 degrees. So this point has shifted here. This is now the shift. It is that way. You can see this point, x is at 270. So if we multiply 270 by times a half, it gives us 135, which is this particular point. And that is why this point now shift to this point, as you can see, shown by the arrow. This point shift to this point. What about this point? This point, x is at 360. When x is at 360 times a half, then it is 180. And as you can see, this is 225, this point. So it follows that it is as a result of 450, which would have been here, multiplied by a half to give us 225. And then the whole graph is repeated the same way. And you can see what was originally a relaxed graph becomes such a squeezed graph, as you can see. This is the graph of y is equals to fx. Yes, we are shifting parallel to the x-axis by multiplication of every x coordinates by half. And that is it. If I may want to use now this one, we are going to see the red graph is the original graph, which is y is equals to fx. The red graph is the original one, y is equals to fx. And if we want to take up the conspicuous point like this one, x is 1 here, as you can see. This is 1, this is 2, this is 3, this is 4. X is 1 here. 1 times a half is actually a half. And that is why this point shifts here. As you can see, the y remain 3, but x for this particular point is obviously a half, as you can see. So this point is at 3. X is at 3. 3 times a half is 1.5. So this is just this point. This point here is 3.5. 3.5. When you multiply this one by half, it becomes 1 3/4. It's just here, 1 3/4. It's not yet 2. This is 3.5. It shifts to the left under the multiplication of all x coordinates by half. It becomes that. But this one is also a very conspicuous point. X is 4. When 4 is multiplied by a half, it becomes 2. And that is why now this graph becomes, this particular point is translated to this one. So obviously, what looked like a relaxed graph, it becomes such a squeezed graph. And you can see, it goes without saying, even on the negative values of x, probably you can see here x is negative a half at this particular point. Negative a half times a half is actually negative a quarter. You can see our black graph now shifting from this particular point to that point, from here to here, because we are multiplying everything by half. And therefore, you can see now how our explanation is. And I would want to probably highlight one of the points, like this one. Let me use this point for at least the point 4, 0 in this graph becomes this point, which is 2, 0. Obviously, you can see 4 translates to 2, meaning that 4 has been multiplied by half. For this particular graph, I may want to highlight a point like which one, minus like this one, which is having 270 degrees and y is -1, as you can see this one. Now multiplied by a half becomes, this is 135 -1. It doesn't change for this, but the y value does not change. You can see in both cases y values do not change, but all x values are multiplied by a half. We have talked about this point into this point. You can see the shift, and we have talked about this point to this point. You can see the shift. That is exactly the power of mutable multiplication inside, which is horizontal stretch of scale factor 1/2. Horizontal means we affect all the x values, and stretch means we multiply. Thank you, and let us meet in the next video.